Hey guys, so here is part 2 of the Day 3 notes. We're now going into graphing logarithms. Now there's going to be two different types or special type of logarithms you guys need to learn. The first one is what we call the common log. So what this means is when we have a base of 10, so when our logarithm has a base of 10, another way we write it is log of x. So anytime you don't really see a base, just know that it's the common log, and that means log of x. Now the next one is what we call the natural log. So remember we talked about how we plug e and you did second ln? Well, that ln represents the natural log. Natural log and e are inverses of each other. Okay. So e is our base. So you could see log base e of x, but another way we just write it is natural log of x. Okay, so that represents the inverse of our e. Now make sure you remember those, okay? Okay, so graphing logarithmic functions. So like we've done before, when we graph logarithmic functions, we will have to move things. So here we have y equals log base b of x minus h plus k. Now you might be wondering, well, how do we do it with the log? Well, what we will have to do is actually rewrite, so this is where it becomes important, rewrite in exponential form. And we're going to do that of the parent function. Then you graph the parent function. Then you translate, okay, with your h and your k. Now another thing is, because we will be talking about domain and range and an asymptote. So this also has an asymptote, but it's going to have a vertical asymptote. And the default is going to be x equals 0. And basically what happens is that your h value will affect the asymptote. Okay, so you might want to pause the video to write this all down. So what we do is, if we have h and k, we rewrite the parent function in exponential form. We graph it, of course. Then we use the translations h and k to move our graph, to move the points. We will have an asymptote. This time it's going to be a vertical. Remember, vertical means it goes up and down. And the default is going to be x equals 0. The h value is going to be the one that affects the asymptote, okay? And once again, h and k is the same as we've done. H talks about going left or right. Remember, if it's x minus h, we go right. X plus h, we go left. And then k goes up and down. So positive k goes up, negative k goes down, okay? Okay, let's go ahead. We're going to do that for our next few problems. So let's talk about the parent function, y equals log of x. Ooh, what type of log is this? We don't see a base here. This is our common log. Okay? So don't forget, any time that we don't see that x or that base, that is a common log. That means the base is going to be 10. Okay? Now the first thing we need to do is actually rewrite in exponential form. Okay, so remember our exponential form, we start with the base, so we want our b to the x equals y, okay, so something like that there. Now don't get confused here when we are trying to do this, especially with all the x's and y's. So when rewriting, we are going to have our base 10. Now we want the exponent part, right? Yes. So when we are doing this, our exponent part is in this case the y, and then equal to x. Ooh, this looks different, right? Because usually our exponent is x. Well, the reason why we'll have to have a y instead of an x is so that it graphs the logarithm function and not an exponential function, okay? So just be careful there when you are rewriting, especially with the x's and y's. Okay, now from here, just like when we graphed exponentials, I'm going to use the same 5 points. I'm going to use -2, -1, 0, 1, and 2, and plug it in, okay? Whoops. But now, instead of putting it in for x, right? So let's say we plug those in for x, we would have to solve for y. That's kind of difficult, right? So instead of plugging those 5 values in for x, we're actually going to plug into y here. So we plug -2 in for y, 10 to the -2nd. Well, that's going to give us 1/100. Okay, if we plug -1 into there, that should give us 1/10. Anything to the 0 power, well, that's just going to give us 1. And then 10 to the first gives us 10, and 10 to the second gives us 100. Okay, so notice it's a lot different than what we did with exponentials. There's the same ideas, but we are graphing a little bit differently here. Okay, now be careful when you're graphing. We still graph x, y, those points. Now know our default asymptote, remember our asymptote is vertical, and the default is going to be now at x equals 0. Now let's go ahead, we're going to plot the points. So we're going to be kind of close to what we can here. It's kind of hard to do. So we have 1/100, and that's at -2, so just kind of do what you can here. Okay, 1, 0. Then we have 10, 1, and then we can't graph the other one. Okay, so here we go. Okay. Now, we don't have any h's and k's, so we don't need to move anything, so we're good to go. But let's talk about domain and range, okay? So domain of logarithm functions are going to be affected here. So notice, do we hit any of the negative x values? No. We really only hit the positives. Now, do we even hit 0? No, because that is where our asymptote is at. So because that's where our asymptote, we are going to go from 0 to infinity. So our domain is going to depend on the asymptote here, okay? But we will always go to positive infinity since we are going that way. Now, what about the range though? Will I hit all the negative y values? Yes, because our arrow is going down. Will I hit all the positive y values? Eventually, yes. So for range for logarithms, it's always going to be negative infinity to positive infinity. So notice things have switched. And the reason they have switched is because, remember, exponentials and logs are inverse of each other. Okay, let's go ahead and do our next one. So we're going to graph y equals log base 1/2 of x. Okay, the first thing we need to do is rewrite an exponential form. Okay, 1/2 is going to be the base. We do not want that to be set to x, okay? The reason being is that then we'll be graphing an exponential and not a logarithm. So we have to have 1/2 to the y power equals x. Every single time you graph a log, it should be always the base to the y, okay, to the y. Now we do x and y. Now I do need to plug in the 5 points into my y value. So it's going to be -2, -1, 0, 1, and 2. If I plug -2 into there, I flip the fraction. 2 squared gives me 4. 1/2 to the -1st gives me 2. 1/2 to the 0 gives me 1. Then I have 1/2 and 1/4. Okay? So I go ahead. My first thing is to draw the default asymptote, which is at x equals 0. There we go. And make sure you write the equation. So I go 4 -2, or I guess I'll start with 1/4. So I have 1/4, and then that's going to be +2. And then 1/2 is 1. And then I have 1, 0. Go right here. There we go. Okay, then I go over 1, 1, 0. Then I have 2, -1. And then 1, 2, 3, 4, 1, 2. There we go. So it should look like this. Still has a curve to it, just like when we talked about with exponentials. Okay. Now here, I don't have any h's or k's, so I don't need to translate anything. So that's nice. Now let's talk about domain. Don't forget, domain is affected by the asymptote. We still have our asymptote at 0, and we are still dealing with all the positive x values, so we go from 0 to infinity. And then we will hit all the positive and negative y values, so we go from negative infinity to positive infinity. Okay? Okay, let's go ahead then. Let's do our last problem with the graphing. We're going to graph y equals log base 2 of x plus 3 plus 1. Okay, so now this is where we do have our h and k. So parent function, let's talk about that one first. It's going to be y equals log base 2 of x. So anytime we do the parent function, we get rid of the h and k. Now I need to rewrite it in exponential form here. So I am going to have my base of 2 to the y equals x. So now I do my xy table as I've usually done, and I use the same 5 points, negative 2 to positive 2. When I plug them in, I get 1/4, 1/2, 0, that'll be 1, 2, and 4. Okay, my default asymptote is still at x equals 0. Okay, and let me plot these. So I have 1/4, negative 2, 1/2, at negative 1, 1, 0, 2, 1, and 4, 2. Okay, so there's my parent function. Now, what I'm going to do is take each of those values and translate it. Okay, remember, h is inside the parentheses, and we do the opposite of what we see, so we are going to translate left 3, and with our k value, up 1. So we're going to move each of those. Now, don't forget, the asymptote is affected by the h value. So that means we will have to move our asymptote to the left 3. So I'm going to do that first, just so I can plot my points correctly. And we need to rewrite that equation as x equals negative 3. So then from there, I go and move everything to the left 3. So 1, 2, 3, and then up 1. And over, yes, 1, 2, 3, up 1. Over 1, 2, 3, up 1. There we go. Over 1, 2, 3, up 1. Over 1, 2, 3, up 1. There we go. So now my green is the original function I should graph. Now we're going to find the domain and range of this original. Remember, domain goes off of the asymptote. So we are at negative 3, and we still go to positive on the x values. So the x values never get smaller than the asymptote. They're always getting bigger. And then our range is always going to be negative infinity to positive infinity for logarithms. Okay? Okay, make sure you watch the last part of these notes where we're going to be talking about both logarithms and exponential graphs.